Hello, and now we introduce an example, which is example number 4. We have square sheet 1 meter by 1 meter, and the thickness for which that sheet is 10 centimeter, which is 0.01 meter. The sheet having modulus of elasticity is 200 gigapascal, which is 10 to the power of 9 Newton per meter square, and is being acted upon by tension force. In the example, he is giving the stress, not the amount of force, but in lieu of that, he is using the stress is equal to 30 megapascal over cross-sectional area, because it's acting this cross-sectional area. Here the width will be 1 meter and the thickness is 0.1. Poisson's ratio is equal to 0.29, which is the lateral strain over the longitudinal strain. He is saying neglect the change in the thickness of the plate due to the compression. He is only worried about the transverse direction. What will be the new dimension of the sheet after applying the stress of 13 megapascal? And he is giving 4 alternatives. Either the sheet will become, so this is 1001.15 millimeter multiplied by 999.852, or 1000.15 millimeter by 999.957, or 1000.15 multiplied by. He is giving several equations. First step is to estimate the longitudinal extension by using the law that the deformation is equal to the force multiplied by length divided by the area divided by the modulus of elasticity. But in our case here, we don't have the force, but instead we have stress. The stress, we estimate the longitudinal extension as follows. We put the stress here, which is 30 multiplied by 10 to the power of 6, and the L is 1 meter, this length, divided by, here we don't have the area because B over A is the stress, so we divide directly over the E, which is 200 multiplied by 10 to the power of 9, will give us 0.0015 meter. This is due to the tension force. The extension happening here will be added to that direction. Instead of 1 meter, it will become 1 meter plus 0.0015. So 1 multiplied by 1000, in order to convert it into millimeter, it will become 1000.15 millimeter. But keeping in mind that this is accompanied by reduction in the length of the transverse direction, and the amount of the reduction will be equal to Poisson's ratio by this deformation. We multiply by deformation, we get a reduction in the transverse direction which we are looking for. 0.29 multiplied by 0.0015, it will give us 0.00435 meter. We multiply by 1000. It's becoming 0.435 millimeter. It is minus since it is compression. So the width before it was 1000 millimeter. It's becoming 1000 minus 0.4535. It's equal to 999.957 millimeters. So the sheet get increased under the action of the force B, but at the same time it get decreased in the width. So for the longitude direction is becoming 1000.15 multiplied by 999.957 millimeter, and this will give us the option number 2, which is correct. Thanks a lot, and hope you have enjoyed by this lecture. Thanks, and see you.